Welcome to Homework Lib.
Hi, so over here we're asked to locate with an asterisk the stereogenic center if any of the following structures, and we're also asked what is going to be the condensed formula for compounds D, E, and F. So in the first thing that we need to do is to identify the stereogenic centers. For D, E, and F, remember that the stereogenic center is going to be an sp3 carbon atom with four different substituents. So, for example, in the case of C, the stereogenic center would be this carbon atom. In the case of B, it would be this carbon atom over here. And in the case of A, we would have more than one stereocenter. It would be this one over here is one stereocenter. This one over here is another stereocenter. And then the CHO, in this case, it corresponds to an aldehyde group. So that would be it. And now for compounds D, E, and F, the stereocenters are going to be this one over here, this one over here, and in the case of F, we cannot find in. Yeah, because the molecule is symmetric, we're not going to have stereocenters. So in this case, now the condensed formula for D, E, and F are going to be associated to the groups that we're going to have present. In the case of D, we have a cyclopropane group. The case for cyclopropane is that the condensed formula corresponding to that is C3H6, and it is often written down in a parenthesis. But in this case, as you may notice, does not give us directly which is the actual compound, right? We can write down different compounds with C3H6 that would correspond to that formula. So whenever we find cycles, it is more often written down the cycle as the cycle of three, and then writing down the condensed formula as CH parenthesis OH CH3. For example, in the case of D. Another alternative is to mix up a little bit of the condensed formulas coming from inorganic chemistry, but this is often not the case. In that scenario, what you would do is to write down the CH coming from this position. That is going to be the main part of the substituent. Next up, we're going to have the CH, OH, CH3 coming from the other part. And what is written in parentheses is going to be the two CH2 groups that we're going to have. And to denote the cycle, what is often done is that you write down a line indicating the connectivity from one carbon atom to the other. As I mentioned, this is often not the case for most of the organic chemistry formulas because that would end up being a complete mess. So what you can do is to simply stick to this way. So following that pattern, compound A would be CH3, CH, parenthesis OH, and next up the cyclopentane. And compound F would be CH3, the cyclohexane, CH3. And with that, it would be all. You can try to write down the formulas as this, but as I mentioned, it is not often used with cyclic compounds. Actually, in most of the cases with cycles, we're going to try to steer away from condensed formulas since they are ambiguous. And with that, it would be all. Thanks and have a good one.